over negative, uh, yeah, it'll be e to the u du over negative 14. But since we don't want it on the inside, because it'll make integrating a bit more complicated, we should take it to the outside. And that's why it's outside. So we simplify this and you integrate, so it's limit as b approaches infinity, negative 1 over 14, e to the u. With the new bounds you put, so it's negative 7b squared over negative 7. Oh, and from negative 7 to negative 7b squared. You plug in your new bounds and you see if your limit diverges, meaning it goes to infinity, or if it converges, meaning it goes into a finite number. Let's see. So limit, we can take out the negative 1 over 14 because it's just a constant. So it's b approaches infinity. And it is e to the u with your new bounds, negative 7b squared over negative 7. This is equal to negative 1 over 14, limit as b approaches infinity, e to the negative 7b squared, which is the same thing as saying 1 over e 7b squared minus 1 over e to the 7. And you notice as b approaches infinity, the exponent becomes infinity, and this whole bottom becomes infinity. So a constant over infinity just becomes 0. So this limit is equal to 0. Don't forget your negative 14. So negative 14 times this negative right here will make it a positive. Therefore, it'll be 1 over 14 times e to the negative 7. Or we can make this a little bit simpler. We can just write 1 over 14 e to the 7. Now this is not where your limit, or not your limit, your series will converge to. It doesn't converge to that because the limit, using the limit will either overestimate or underestimate what your series converges to. The only thing you can tell from the integral test is if your series converges or diverges. And then for this we can write series starting at 1 k e negative 7x squared converges by integral test. Put a box around that. Highlight it with green. Highlight the question with purple. Underline to separate the question, and we can go to question number 2. Question number 2 is the series k starting at 0 to infinity 8 over k plus 5 square root. Now this can seem a little bit complicated, but we can simplify this down. This is the same thing as saying the series starting at 0, 8 over k plus 5 parentheses to the 1 over 2 power. That's the same thing as saying square root. Okay, now remember, we can make our function mimic, well, our series mimic a function. Therefore, x would be basically mimicking k. Now let's write down the requirements. Is it positive? Is it continuous? And is it non-increasing, meaning decreasing? You gotta determine that your interval, x is greater than or equal to 0, because k mimics x, and k starts at 0. Therefore, x has to be greater than or equal to 0. Now let's see. So your f of x is equal to 8 over x plus 5. Remember, it's x because we're mimicking k with the x. So let's see. Is it continuous? Plug in 0. So f0 is equal to 8 over 5 square root. Okay, yep, it is continuous. Now, is it positive? Well, you see right here, it's a positive number. Therefore, it is positive as well. Now, is it non-increasing? Let's check. The easier way you can solve this problem, instead of having to take the derivative, is that if your numerator has just a constant and your denominator is the one that has a variable, if your denominator keeps increasing and if your denominator keeps increasing but your numerator stays fixed, then your overall function will be decreasing. And that way you wouldn't have to do the low d high minus high d low finding the first derivative. So we can say that this is also non-increasing. Okay, now let's take the integral. From 1 to, oh actually not 1, 0, 8, we can just say x plus 5 to negative 1 over 2. Remember, it's negative right here because it's the same thing as saying 8 over this whole thing, or we can just say it's times the negative exponent of it. Negative just means it belongs on the opposite side, because if you were to have, let's just say 8 over x to the negative 1, then this would just be 8 times x. It can be in the numerator or the denominator. The negative just means it has to be on the opposite. So if it's a numerator and you have a negative exponent, then it belongs to the denominator. If it's a denominator and you have a negative exponent, then it belongs in the numerator. Okay, you can use this integral right here, dx. Remember, this is an improper integral, so we have to use limits to be able to solve this. B to the, from 0 to b, and we factor out the 8 because it's just a constant. So x plus 5, negative 1 over 2, dx. Now we just use substitution. U is equal to x plus 5, du is equal to dx, because the derivative of this at the top is just 1, and 1 times dx is just dx. So also don't forget to change your bounds. So you plug in the first bound, which would just be b plus 5. Your second bound is going to be 0 plus 5, which is just equal to 5. And then you just do normal use substitution. So limit as b approaches infinity times 8, because we took out the 8 over there. And it's going to be b plus 5. And then from 5 to b plus 5, it'll be u to negative 1 over 2 du. Now we integrate this like if we were to just integrate x. So we add 1 to the numerator and divide by that new numerator. So this is equal to the limit is b approaches infinity, 8. And since it's a constant, we can just take it outside. So we just multiply the whole limit by 8. 8 times the limit is b approaches infinity, u to the negative 1 over 2, which is just, we can just add 1 to that, which is 2 over 2. And then it'll be u to the 1 over 2 divided by that new numerator, which is the same thing as saying 2u 1 over 2. We plug in the new bounds, b plus 5, and then 5. We can see from here that our integral, well, let's not get ahead of ourselves. So this will just be a limit, and we can just take out this 2 right here, and so it'll be 16 at the front, b approaches infinity, u to the 1 over 2, and we just plug in our bounds into our u, which would be b plus 5 minus 5. And this is all square root into the square root. Notice right here, you have a b plus 5 and b becomes infinity. So as b approaches infinity, this right here will approach infinity. Therefore, it diverges. Oh, it becomes infinity, therefore it diverges. Diverges. So we can say that the series starting at 0, and it is 8 over k plus 5 square root, diverges using integral test. Using integral test. I'm going to do one more example. Let me look at this. Let me see. Okay, yeah, here's